Now we are going to talk about the confidence level, level of significance, and critical region. So now if we divide the confidence level and level of significance, basically the sum of confidence level and level of significance is 1, and you can also call it 100%. 100% is divided into two parts. One is confidence level and another one is level of significance. If we do a sum of confidence level and level of significance, then we will find 100%. At first, we will deal with confidence level. So, what is the confidence level? In case of a point estimate, it shows how sure we are that the estimate represents the true value of the population. We have a point estimate, and how sure we are that the point estimate that we have obtained from the sample is actually representing the true nature or true value of the population. That is the confidence level. In case of interval estimate, it shows how sure we are that the true value that we have estimated um, lies within an estimated interval. Here this true value is nothing but the population value. In case of point estimate also, the true value is nothing but the population value. So the confidence level is telling us that how sure we are that the true value or the population value is being represented by the estimate or by the estimated interval. So the confidence level is basically represented by a percentage. If the confidence level is 95%, what does it mean? That means if we take n number of sample from m number of times, for m number of times from a n number of population, then it means that for 95 times out of 100, the estimate represents the true value of the population, or the true value lies within the estimated interval. Let me give an example, then it will be much more easier for you to understand. If confidence level is 95% and population size is 1 lakh and the sample size is 40, then we can say that we are taking random samples of size 40 for 100 times. Okay, we are taking random samples from the population of 1 lakh, and the sample size is 40 for each time. And for how many times we are doing it? We are doing it for 100 times. So we are taking samples of size 40 for 100 times. And if the confidence level is 95%, then it means that for 95 times out of 100, the estimate represents the true value of the population, or the true value, that is the population value, the population parameter. It can be population mean, it can be population variance, population SD, that lies within the estimated interval. So what does the 95% confidence level means? That we have a population size, we are drawing a sample of a particular size from that population, and for how many times we are drawing the sample? We are drawing the sample for 100 times. And if the confidence level is 95%, that means from that 100 times, for 95 times, the estimated um, statistic will actually represent the true value of the population parameter, or the estimated interval will actually consist the true value of the parameter, or true value of the population parameter. In an alternative way, we can say that if confidence level is 95% and population is 1 lakh and sample size is 40, then we can say we have taken random samples of size 40 for 100 times. Till this part it is same. And for 95 times out of 100, the null hypothesis is accepted. We all know that null hypothesis takes the value of population parameter equals to the population parameter value. That means any population parameter, that is mean or the variance or SD, whatever value is given or whatever value is accepted to occur on the basis of the sample statistic, that is supposed to be accepted. Okay, so confidence interval in an alternative way can be expressed as the time, how many times out of 100 we are actually accepting the null hypothesis. If we are if the confidence interval level is 90%, then we are actually accepting the null hypothesis for 90 times out of 100. What is the conclusion? Higher the confidence level, higher will be the strength of the test. Obviously, right? If the confidence level is 99%, then we can say that for 99 times out of 100, the estimate represents the true value of the population, or the true value lies within the estimated interval, or the null hypothesis is accepted. So if the null hypothesis is getting accepted for 99 times, or for 99 times the true value of the population is being represented by the estimate, so that is a very good thing, right? So higher the confidence level means that strength of the test is also higher. So that's why the confidence level, which is also known as the power of the test. Similarly, as we have said earlier, that confidence level and level of significance are basically two sides of one coin, right? So level of significance is just nothing but the inverse of confidence level. It shows that how many times the estimate does not represent the true value of the population. So that means if level of significance is 5%, that means if the population is 1 lakh, sample size is 40, everything is same as before, then we can say we have taken random samples of size 40 for 100 times, and for 5 times out of 100 the estimate does not represent the value of the population, or the true value does not lie within the estimated interval. Or similarly you can say that the null hypothesis is not accepted for 5 times out of 100, or we can say that null hypothesis is rejected. Higher the level of significance, lower will be the strength of test. So basically, if you have understood the confidence level, then level of significance is just nothing but the inverse or opposite of that. So this is very easy to understand. Now we are heading to p-value. P-value does not represent the level of significance. Some of us has the misconception that p-value actually represents the level of significance, but it actually does not. P-value expresses the likelihood of rejecting the null hypothesis, which is true. Suppose we have a null hypothesis and an alternative hypothesis, and the null hypothesis is true, sorry, but we are rejecting it. If the null hypothesis is true and still we are rejecting it and accepting the alternative hypothesis, then we are committing an error that is called type 1 error. So if we are doing this thing, if we are actually doing this thing, that means we are rejecting the null hypothesis which is true, then that thing is represented by p-value. If p-value is 0.3, that means the probability of committing a type 1 error is 30%. Let me express it. That means out of 100 times, 30 times the true null hypothesis is rejected. So if the p-value is 0.3, that means out of 100 times, 30 times the null hypothesis which is true is rejected. Of course, it is a big issue. That's why we expect the p-value to be very less. If p-value is 0.01, that means the probability of rejecting a true null hypothesis is 1% only out of 100 times. Only one times the true null hypothesis will be rejected. Well, that's very good. Now we are going to understand the interpretation of p-value and level of significance. If p-value is 0.03 and level of significance is 5%, that is 0.05, we can say that the probability of rejecting a true null hypothesis is 3 out of 100, and the likelihood or the probability of rejecting a null hypothesis is 5 out of 100. That means the coefficient which is having a p-value of 0.03 is statistically significant at 3% or more than 3% level of significance. What is statistically significant means? Statistically significant means statistically acceptable, means showing good result. Let me show it by an example. Here, as you can see, our x variable 1 has a coefficient of minus 0.006, and that coefficient has a p-value of 0.742. uh, I have taken that value, I have taken the value as 0.135, but still we can understand it by this value also. P-value of the coefficient of variable 1 is 0.135. We have actually it should be 0.742, but if you can understand the interpretation with the help of 0.135, then you can easily understand the interpretation with the help of 0.742. It means the coefficient that is statistically significant. So if the p-value is 0.135, just multiply this p-value with 100. You will get the value of 13.5. So that means the coefficient will be statistically significant at 13.5% or more than 13.5% level of significance. But if the level of significance is less than 13.5%, that is 5% or 10%, then the p-value is showing that the coefficient of variable 1 is not statistically significant. If the p-value, if the level of significance was 20, or if the level of significance was 20% or 25% or 15%, then we could have said that the coefficient is statistically significant because the p-value is 13.5. So the p-value has to be uh, less than the level of significance. If the p-value is greater than the level of significance, then we can't say that the coefficients of the regression are statistically significant.